Okay, these are the examples for Geometry A, Credit 1, Lesson 1.2. All right, so first of all, we're going to talk about perpendicular lines and what we have that's true about perpendicular lines. So perpendicular lines are two lines that form a right angle or that intersect at a right angle. In fact, let's make this a line here, actually. There we go. All right, so what's true about perpendicular lines? Well, perpendicular lines will always be in the same plane or the same, and we talk about a plane, we're not talking about an airplane here, but actually a plane referring to a flat surface. So notice these lines are not extending out or into the board or the wall here. They're on the same flat surface. So they're on the same plane, and for that we call those coplanar. Like two people that work together are co-workers. So these are coplanars, meaning, spelled that wrong, meaning that they are on the same flat surface or the same plane. So as we mentioned already, that they intersect to form a right angle. And let's go ahead and write that up there. So the lines intersect and they form a right angle, which is also a 90-degree angle. So we'll point that out as well too. That should help you out. And then lastly, well, that's actually it. So that's everything that's true about perpendicular lines. Again, they're on the same plane. They are coplanar. They form a right angle, which is a 90-degree angle. All right, so that's our example for the information for number one. For number two, we are going to first of all talk about what a segment bisector is. And so a segment bisector is any line, ray, or segment, I suppose, or point that takes a line segment. We're going to call this line segment AB here, and divides it into two equal pieces. So notice the line cuts it, AB, into two equal pieces. The ray here cuts the segment into two equal pieces. And so does this point here, would also be called a midpoint, but it is also a segment bisector because it divides that segment into two equal pieces, or we can call it a segment bisector. Next is a perpendicular bisector. So once again, it's a bisector because it does divide the segment into two equal pieces, but this line is perpendicular or forms a right angle with the segment that it's bisecting or cutting into two equal pieces. Finally, an angle bisector. So here we have angle ABD, and actually let's draw this ray to show it to you. So we draw a ray, and we're going to call that ray BC. And ray BC takes the big angle ABD and cuts it into two equal pieces. So that is an angle bisector. So that information should be what you need in order to answer problems 1 and 2. All right, moving on, we're going to talk about next the way that we can name angles. So we'll quickly erase everything here. And let's go ahead and put an angle up here. We're going to call this angle RST. And let's talk about the different ways that we can name an angle. Now, one first way we can name an angle is to call this, just name it by the vertex, angle S. So that is one way to name it. We can also name it with 3 letters, using the vertex and a point on each from each side of the angle. And there's 2 ways we can do that. We can go angle RST, kind of alphabetical there, or we can go the other way as long as we keep the vertex in the middle. So TSR would be another acceptable way to name that angle. And then finally, sometimes they'll just number an angle, like they'll call this angle number 1, and you can refer to that as angle 1 as well, would be another way to do that. All right, so that's naming an angle. And again, that's our example for problem number 3. So for number 3, that's the information that you'll need. For problem number 4, and here in lesson 1.2, let's talk about the different types of angles. So if we have an angle, we've already discussed a right angle. So a right angle has that square corner there. So that is a right angle, which we already know measures 90 degrees. But right now we're just going to focus on the names of them. Now next, if an angle is wider or more than 90 degrees, between 90 and 180 degrees, we call that an obtuse angle. And so an obtuse angle, actually maybe we better put the measurements. So a right angle is 90 degrees, and an obtuse angle is between 90 and 180 degrees. Let's go ahead, make sure that's seen on the screen there, okay? Let's put it right down here. So more than 90 and less than 180. Now an acute angle is an angle that's less than 90 degrees. And so, and of course more than 0, so that would be anything that's more than 0 or less than 90 degrees. Finally, the last type of angle we have that we're going to talk about is a straight angle. And a straight angle looks exactly like that, like a line. And it is a line, but as an angle, we could call that an angle. And a straight angle measures exactly 180 degrees. So a straight angle measures 180 degrees. So that's the information you'll need for problem number 4. All right, so now let's take a look at examples for problems 5 and 6 as we quickly erase everything up here, as quick as we can. All right, so for number 5, this is our example for problem number 5. And let's go ahead, we'll just use the same letters that they do in the packet. And we'll just use different numbers to show you how you do this here, how you work this problem out. Okay, so it says, for number 5, it says find the measure of angle KLA. So KLA is in here. So that's what we're trying to find. So that's where we're going to put the X there. And if the measure of angle ALM is equal to 88. So ALM is right here, but instead of 88, we're going to use 55. And the measure of angle KLM is the big angle here. And we are told that that measures 158, but in our example, we're going to use 140 degrees. All right, so the way we set up our example is this. So whenever we divide an angle into 2 smaller angles, the sum of those 2 smaller angles is equal to the original big angle. So we can set up our equation like that, 55 plus X, the 2 smaller angles added together equals the larger angle, equals the 140. And so now to solve this, just one step, because in order to get X by itself, all we have to do is get rid of the 55. That is a positive 55. So we're going to subtract 55 to both sides. The 55s over here cancel out. We bring down the X, and 140 minus 55 gives us 85 degrees. And so the measure, and the way so that's solving the equation, but the way we want to write our answer, the measure of angle KLA, and of course we could also call that ALK, is equal to 85 degrees. All right, so that would be KLA right in there. All right, so that's our example for number 5. Number 6 is similar, and but there is one little thing that's different. So let's go ahead and do an example for number 6 here. And we'll do this pretty quickly, hopefully. And let's see. So it says use the figure below. And let's go ahead and label everything here. We've got C, D, E, and F. Now, I know that looks like a bisector, but since we're not told that this is a bisector, we can't assume that. So it says using the figure below, Angle FDC is 46 degrees. So let's make that a little clear. FDC is 46. In our example, we're going to use 33. And it says, what is the measure of angle B? So we mentioned earlier we can give a number to an angle, call that like angle 1. They're just calling this B here to represent the number of degrees of this smaller angle here. All right, so now you might feel like, well, we're not told a lot of information here, but we are told enough. So we are going to add, just like we did in the last example, the two smaller angles added together equals the big angle. So 33 plus B equals what? Well, what is the measure of the big angle? You might be thinking, well, they didn't tell us that. Well, they kind of did actually, because by putting the right angle symbol there, that tells us that the big angle is a right angle, which means it measures 90 degrees. And so that's how we can determine the measure of the big angle. Now to solve for B, we got to get rid of this 33. So very similar to problem number 5, or the example for number 5. And so that's a positive 33. So we're going to subtract 33 to both sides. The 33s on the left side cancel. And then over there on the right, 90 minus 33 gives us 57. And so B would be 57 degrees. All right, that is it for lesson 1.2. Again, pause, rewind, rewatch the video as needed. And good luck and with the work, and God bless. See you in the next video.